Welcome to All Things Engineering by EIT. This is a podcast where we cover industry insights, emerging trends, and practical knowledge across engineering disciplines.
Hello, my name is Shasha Wang. I'm a lecturer in civil engineering at Engineering Institute of Technology, EIT. And I'm based in Melbourne campus in Australia. I have about 20 years experience in civil engineering research and education. That's about me. Yourself?
Yeah, myself. So my name is Carolina Asenjo. So I have a undergrad in production engineering, which is similar to industrial engineering. I studied back home, which is Venezuela, but I am based in Perth, Australia. And I came to Australia to do a master's in commerce and marketing, kind of where I joke I switched to the dark side. But I've somehow made it. I've got a bit of a passion for science and also the social sciences, I guess. So I found my spot or my niche doing marketing in engineering. So that's where I've been. Finished my undergrad in 2007, so about 18 years, and my postgrad in 2009. I'm also working at the Engineering Institute of Technology in the analytics and strategy area. So today I think we're going to chat a bit about our insights over the years of how, I guess, engineering has shifted, what's important nowadays, what we're noticing in terms of skills in demand, and I guess even, how it's all been impacted a little bit as well with AI. And you've been a lecturer, that would be an interesting aspect of how it's, changing the teaching and learning side of things. Can I ask you how you first got interested in engineering, Shasha? What made you, go into?
Well, I think my interest in engineering, especially civil engineering, was I think it's from my grandfather. My grandfather, he led a small team consisting of his relatives and built a lot of houses, including the one in which he raised his big family and the one in which I grew up. So he can build traditional Chinese timber houses, and he can also build traditional brick houses with those beautiful imperial roof decorations. Wow. The house he built for my family, is a modern reinforced concrete one with brick walls. I can still remember, many years ago when I visit the construction site when the construction was going on. I can still remember how I saw how my grandfather and his team built the house brick by brick, layer by layer, and how the house rose from the ground day by day. It was just so
beautiful,
so
isn't
amazing.
it? From design to seeing it and obviously living in it. That's
yes, so
very rewarding. Yeah.
So we finally moved into the house, and I felt so excited indeed and happy. And I was thinking, what if I can also build my future house and build more houses for others? So that's probably the first time my interest in civil engineering was triggered.
Yeah.
Then, how about you, Karina?
Yeah, for myself, it was a little bit hard to escape it, I think, because my father studied electrical engineering and my older brother followed with electronics engineering. And my older sister, so I'm the youngest of three, did production engineering. So I kind of grew up seeing a lot of the engineering projects and terminology around the house. And I was quite against it, to be honest. When I was finishing my high school years, I thought I'm not going to do anything but engineering. And I applied for all these other degrees because I was adamant that I wouldn't do engineering. But anyway, I ended up getting into all the options I wanted, and engineering was starting first. So I thought, you know what, I might as well just go in for that trimester and see how it goes. And that was it. The rest is history. So but as I said, I did always like science, physics, and math. So it felt comfortable, to be honest. And the fact that I could later on still do be in the engineering space, but from the marketing side, that I've also enjoyed from I had exposure through my internships in production engineering to launching new products to market. And although I was in supply chain, because that's a lot of what industrial and production engineering do, we were invited to these focus groups and to market launch events and whatnot. And I thought that was all quite interesting as well, the psychology behind producing something that people want. So yeah, that's a bit. So I guess if you could go back to your first day as an engineer, like when you first, I guess, got out of your degree, what would you tell yourself to prepare you for what you've seen and learned over the 2 decades of experience you've got, Shasha?
Well, I think I grown up in such an environment that people actually value a lot the first degree. This is good in the sense that the students put their whole self in study, trying to get admitted to and graduate from good universities. And indeed, this is what I was doing at that time. But the first degree, I think, is important to launch engineering professional life. However, over the years, it's become more and more clear to me that the first degree is not the end of learning. It doesn't actually teach you everything, and it is not a guarantee of success. I believe successful education actually teaches and trains students how to learn.
Yeah.
And yes, engineering, in fact, is a field of lifelong learning. The technologies and the standards, they change rapidly. What you learn in year 1 might be totally different by the year 10. So continuous learning through experience, professional development, and the short course is essential. Yes, and indeed, it's actually very common that nowadays we can see the working professionals, they come back to take further studies to upskill themselves in both maybe vocational education and training, and as well as higher education sector.
Yeah.
So yeah.
Well, the world's very fast-paced, isn't it? Technology is moving quickly, so absolutely. I also thought about this point myself, and it would be around the never stop learning, questioning things, and I think just giving things a go, and if you'll fail and you'll succeed, but you can learn from both. And I think that accountability in terms of like if you own your mistakes and learn from them, and that's how we grow. So definitely, I also think that if you think when you go into your degree that by the time you come out you'll know everything and you'll be, as you said, successful, absolutely not. And then I think most of us come out and realize everything you've learned for all those years as you go to the field is like, what? How do you actually do it now? It's not quite the same. So yeah, definitely learning on the go and trying things. Yeah.
Yes, and Karina, actually, I have another point to share about kind of lesson that I've learned is actually how we view and treat failure. So failure, I think it is a data point, but it's not the final point. For example, in academia, in which I'm working in, we encourage students to experiment and learn from the mistakes. So I believe in the professional world, failure can seem catastrophic. However, major lesson is that a setback, it is an opportunity for analysis and for improvement. For example, a bridge design that doesn't hold up in a simulation, or a research proposal that gets rejected, it is not the end. It is not the dead end. It is a chance for us to go back to the design, identify the flaws, and create a better solution. So so this is one of the other.
And I guess it's a challenge where experience is so valuable, right? Because as you do things and you learn, you improve. But I guess if you're young and starting, you don't have that experience. So I would say it's that the mentorship, the communication, that networking, like working as a team, learning from obviously others if you can that have been in the field or have done it, it's invaluable. So definitely those soft skills, which are often, they're really not taught really at all, or almost at all in engineering, and yet they're really important when you're in the actual professional environment, because you have to you have to listen, you have to take on feedback, and yeah, it's quite important. I remember early on, yeah, in supply chain when I was working, we had to launch a new product and we were modifying a production line. And my manager, who was also a female production engineer, actually, she taught me the importance of questioning things. And I think it's not, don't want to go into whole, sexism and genders and whatnot, but yeah, the plant was full of male, technicians and engineers. So for her to prove a point and to be heard, I recall it being a bit of a thing. And there was an issue with something, and it was because they were trying to replicate how this product was being made in another factory in another country, actually. And there was this problem that wasn't working, it wasn't coming out the same way. And I remember driving to the factory with her and brainstorming, okay, how could we fix that problem, what could we do physically and mechanically to get it right. And when we got there and we looked at the problem in face to face, and they showed us what was happening, and she said, well, but do we really need it to be working the other way? Why? And she kind of raised the question, and it was just a matter of, again, they were trying to replicate exactly what was being done elsewhere, and following, I guess, that book. But we said it's not an issue, actually, what we have here, it's okay. So there was no problem after all. So I think, yeah, it's questioning things is important, not necessarily because you've been told or because it's been done in a certain way. It means it's the only way or the best way. So having that courage almost to, question
Yes,
things, think outside the box.
yes, that's true.
Yeah. So is there anything, I guess, in terms of skills, Shasha, that you are, in civil, obviously, so might be more to the field you can talk to, but any particular skills you've noticed that are quite important for, I guess, professionals or even young engineers coming into the field that they need to ensure they're harnessing and developing further now?
I think I believe that they need to have both technical and the softer skills.
Yeah.
Then in terms of the specific technical skills, it might be different if we are talking about different engineering fields. They may vary, but in my opinion, they must be a blend of fundamental engineering principles and also modern software proficiencies nowadays, and more importantly, practical field knowledge.
Yeah.
So for civil engineer, for example, because I'm my background is civil engineer, so the technical skills needed. I think firstly the core engineering fundamentals like structural analysis and the design, and geotechnical engineering, fluid mechanics, hydraulics, a lot of different aspect of civil engineering. And of course, I also want to emphasize the software and the technology proficiency. Nowadays, we are using a lot of new technologies different from many decades ago. For example, we are using CAD and the drafting softwares, building information modeling softwares, structural analysis and the design softwares, and so on. And in addition, project management software we even have. And but apart from that, I think practical and the site skills are also very, very important. For example, we need to know how to read and create construction documents. We need to do cost estimation and the budgeting and the construction management. And we need to do site inspection. So all of these are very important in addition to I think regulatory knowledge, such as we need to understand and master relevant local and international codes and even environmental regulations nowadays. So those are actually the important, I think, technical skills. But I think softwares are as important as technical skills.
Yes. Which soft skills would you reckon would be most critical?
There are so many soft skills, but among all of them, I think, in my opinion, communication is probably the most critical one, which could actually include technical writing, verbal communication, and active listening.
Yeah.
We need to write clear, concise, and accurate reports and proposals, emails, and maybe technical specifications. And we have to explain complex technical concepts to non-engineers, including, for example, our clients, public stakeholders, and maybe even government officials in some scenarios in the way that they can understand. So yeah, that's why I think communication is very important. But of course, apart from communication, we also need to have problem solving, critical thinking, teamwork, collaboration, a lot, right?
Yeah, absolutely. You know, I one of the projects I've been involved with in the last just over a year, probably closer to 2 years, is this gathering insights on precisely that, the skills in demand, both technical and soft, for engineering professionals. So even including our technicians and technologists, so looking at a occupation level as well. And we're doing that by looking into actual job adverts in some key markets, 7 of them at the moment, and actually, seeing what the data is telling, or what are employers looking for, because that's kind of the source of truth, right? And you're right. It was interesting that across the board, and I'm talking about all the different disciplines, occupation levels, and markets. We looked, the last report, we've done a few versions now, but the latest one from February was over 316,000 job adverts that we've analyzed. And again, across disciplines, occupation levels, and those markets, the soft skills were definitely mentioned. So they were predominantly included in the adverts. And the top 3 were exactly what you've said: communication, teamwork, and problem solving. So for anyone that hasn't considered and think they can, kind of work on their own bubble, no, it's definitely being asked by employers. So if you don't think you're maybe up to scratch in an area, it's worth doing a little bit of preparation and training, as you said, some professional development. I guess just quickly touching, because you've obviously covered civil brilliantly, civil engineering. The report is available on the EIT website for anyone who wants to dig around. There's actually an interactive dashboard as well, which is quite nice, because then depending on where you might be or your discipline, you can kind of play around with the filters and go deeper into what you really want. But generally speaking, if I can, we noticed that, for example, you said it before, one of the trends we've noticed is professionals constantly being more and more asked to be able to integrate systems and to adapt to new technologies. So, as you said, those foundational skills and knowledge is important. You need to have that, the basics, that understanding and the knowledge. But I guess what we're noticing in the adverts is that they want people to be able to use that, but in today's kind of systems and technologies, and more things are obviously coming together now, and communicating with each other and integrating. So that's something that's been, I guess, highlighted from the report. In the area, for example, mechanical engineers, there's a lot of repair, diagnostics, and hydraulics skills related to that are being asked. For electrical electronics, it's a lot of control systems and troubleshooting and instrumentation. Environmental engineering, which we looked at as well, highly mentioned, is water treatment aspects. Software development, that's the whole programming skills, obviously, but I know AI is kind of being very disruptive in that space, but we'll get to that shortly. I'm conscious of time. We probably have to be wrapping it up in a minute, but the programming and AI and how that's been changing, but the cloud platforms, technologies, and cybersecurity, obviously quite big. And I think, for chemical, maybe that's the last one, we noticed a lot of the process optimization as well as project management. So across all the disciplines, and on the tech side, maybe more than the soft, there was project management, maintenance, and design were the most popular ones, which you could probably encapsulate. Most of the disciplines were asking for it, but being more specific, you can see certain skill sets that are in demand. And the same with the occupation level, obviously more hands-on sort of welding, for example, techniques if you're in mechanical engineering as a technician, rather than, it's more project management if you were at a senior engineering level. So that was quite a quite an interesting project. Lots to still dig out, I think, from it. But so maybe, yeah, I guess moving towards the end, maybe of our chat, the future of engineering. I don't know if there's any thoughts on AI and learning and what you're finding, and yeah, I guess pros and cons, so without getting too polemic, but
Yeah, yeah, AI does actually bring significant challenges to engineering education, for example.
Mm,
The first and the most immediately challenge that I think is the misuse of generative AI for completing
yeah,
assessments and
yeah,
writing reports,
yeah.
which actually raises significant concerns in relation to academic integrity.
Mm-hmm.
Because traditionally, educators will assess a student's ability to get the correct answer, but nowadays AI can produce the answer. So this
Mm-hmm.
actually forces educators to uh, rethink the assessment tools and pushes us towards more uh, in-person exams,
Yeah.
and also project-based learning, oral presentations, and the
Mm-hmm.
assessments that require uh, creativity and critical thinking beyond what current
Mm,
AI can easily replicate. And correspondingly, I think there is a need to integrate AI ethic and also impact into engineering courses. So I think in addition, in the age of AI, I think the engineering education will actually evolve from focus on calculation and information recall into curriculum improvement of many existing education programs and the curriculum design of new interdisciplinary programs. So this also
mm,
actually pushes us engineering educators to invest significant amount of time to be trained in AI and to restrain and redesign our courses. But
mm,
ultimately, it is actually about to train our students, to train engineers who are not just the users of AI, but the conductor, masterful
mm.
conductor of AI. So they
Yeah.
must, our engineers, our students, they must be critical thinker who can actually leverage AI's power while applying deep fundamental knowledge and
Mm.
rigorous ethical reasoning to ensure that
Correct.
technology
Yeah.
can serve public safely and
Yeah.
effectively, I think.
Use carefully and smartly. Obviously, it is a tool that's,
Yes.
been made available to all of us. There's no hiding under a rock to not use it. But I think it comes down to exactly for me, as you said, the critical thinking, because I've used
Mm.
AI a little bit. I did. I'm kind of more of a late adopter to it because I had my reservations about, I don't know, maybe the pride in doing something yourself, right? And feeling that you've accomplished it and doing a report and that I knew it was my words, it was my thinking, it was what my thoughts going into it. But anyway, it does help. Obviously, it speeds up things, but it's the critical thinking. And I think everyone who's used it a little bit, and if you are being critical, you realize it can make mistakes, it can get things wrong. And yeah, whenever I've done some little bit of analysis with it and calculations, and then straight away I can see, well, that doesn't make sense, and you question it, and it's like, oh, thank you for bringing that up. And it's so yeah. We just got to be careful, and I think ultimately, what do you want to get out of a degree in your career? Like if you want to learn and you want to be good at what you're doing, you probably don't want to rely on a tool that kind of comes up with the answers and that you're maybe, yeah, not even sure then if they're right or not. You gotta yeah, apply your own thoughts to it and your
Yes.
criticism really. Yeah,
Yes. We have to have our own judgment. Yes.
absolutely. Well, I'm trying to think, but yeah, I think that's what we were hoping to cover for today. I don't know what, maybe to close off, if people obviously want to reach out to us on LinkedIn or connect and talk further, or if got any suggestions of the things you want to hear from or the All Things Engineering podcast, then we're happy to hear that. And yeah, I think the opportunity to continue learning and improving. So obviously through EIT, that's a lot of what we're doing. This part of this research is what else is being asked that we're not necessarily doing at the moment that we should, and constantly thinking of other courses and things that we need to integrate into our programs to make them as relevant to the real work. The idea at the end of the day is people being able to improve their careers and their lives' actual outcomes, not just another qualification, although I love studying, but it's not a qualification for the sake of it. It's things that actually give you value, I think, in the real life, in your work and your career.
Thank you so much for tuning in today. If you enjoyed this episode, make sure to follow and subscribe, and so that you don't miss future conversations. We've got some exciting guests lined up and a lot more to share. So do connect with us on social media and share your thoughts, questions, or experiences. So until next time, stay curious and keep pushing boundaries. Thanks, everyone.